Look into my freaking eyes. You know what they see? They see a bitch. Listen here, you gooners. We're gonna be doing something a little different, which is gonna be really nice. We're gonna be making a fake snapper. It's gonna be pretty cool, actually. It's what I use for my diamond, which I can just boink like that. This is not using a snapper whatsoever, but it follows me around like it is one. Pretty cool. We're gonna have to do a little bit more flux than last time, so just go ahead and be prepared for that. All right, let's get into it. So the first thing that we want to do with our dev tool is to get a sphere. I'm just choosing the sphere because, you know, it's more follow material than a box. So we get a sphere, we shrink it down to, like, you know, a follower worthy kind of size, whatever you feel like. Next, we're actually going to put some Dynvars on it. So we have our sphere right here. We're just going to name it follower. After we've named it, then we can create a child. We're going to call this one DVs. We can create another child to the follower, and we'll just name this flux for now. So now we'll put our DVs here and our flux here. On DVs, we need to be able to get a reference to us, right? We also need it to get a reference to itself. So just like I've done in my previous videos on Dynvars, we are just going to look for dynamic reference variables right here under data and dynamic. First one we're going to do is user, and the next one we'll do is slot. So now I have user and I have slot. For the user, I'm just going to call it follower slash user. Also, I'm an idiot. I forgot to put a space, dynamic variable space on the object. I'm going to do that real quick. Yeah, don't forget your Dynvar spaces, because it needs that in order to communicate with everything else that exists underneath it. So dynamic variable space you can see here, which is under data and dynamic as well. Oh my god, I did two of them again. Right, I'm just gonna call this space follower. I'm gonna go to dynamic variables and I'm gonna call this follower slash follower. So follower, and I'm gonna put the follower right here as the reference. The user, we're gonna do a little differently. So we're going to use what's called user from username, and that is going to be under users. So don't worry about how my flux looks. It's gonna operate the same way no matter what. So username, you can look up any username that you want. In our case, it's gonna be us. Ignore case is just ignoring whether it's uppercase or lowercase, and then allow partial match. So you could type it halfway, right? Half-assed, and it will still get a reference. So I look here, I pull this out and I say STU. It's not going to pull up anything over here just yet, but if I pull out ignore case and allow partial match, then we see it automatically gets my reference. One other thing that we can do that this is going to be really, really useful. So let's move this up real quick and take a look at these Dynvars. We have the user and the slot. We can do one of type string, and string, when it comes to components, are values always. When they come to flux, they are objects always. Don't ask me why it's inconsistent. Just remember components, values, flux, objects, strings. Fucking weird. So we will do another, we'll do a dynamic value variable under data and dynamic. And here we will do of type string. It is not capitalized. I repeat, not capitalize. Let me just break my so we get type string, and what this will allow us to do is to be able to use this data as input data. So then we would get a dynamic variable input. So here, variable name, I'm just gonna name this follower slash user name. You could also have it be follower user, and it can share that exact same name. It just outputs whatever data specifically, which is really cool. So I'm just going to call this follower username. That way, no matter what I type in here, it will output to this data here. So now what I'm going to do is I'm going to get a dynamic variable input of type string, which is going to be an object. So a dynamic variable object input, which is under variables and dynamic. And again, we look for string lowercase. Ooh, wait a minute. Deselect. There we go. So now I don't have to keep typing it and opening my flux into this field anymore. So I can just get rid of this because this dynamic input is going to always be in reference to whatever name I give it here, right here. So this is always going to be the same as this. Right now it is null, and that's fine. We know it's going to work once we pack it. So let's just go ahead and pack it. Under flux, we can create a child and we can call it ref ID flux. Sure. Boom. Ref ID flux. Now let's just go ahead and pack this underneath it real quick and then unpack. And now we get STU, which is correct. And sure as shit, there's me. Stutters. So now we have this. We need it to constantly reference to the individual, right? So we need to get a permanent reference to ourselves. We're going to use a dynamic right of type user. So now we plugged it in. So we have all this material here. We need a reference to the sphere, which we do right here under DVs, follower. So we need another input of type slot. And finally, we need the path. Pretty sure you understand the drill. Here, we just go to follower user and we plug it in here. So what's going to call this? We're just going to have it be onloaded. So when the object loads into the world after you spawn it out, it will automatically send a pulse, and then this will receive that pulse and get the user. Back you up a little bit, get on my face. You in my dynamic variable space, brother. Get it? Bad joke. So here, with the input, we're just gonna do the same thing. It's gonna be follower. And now we get the final node, which is onloaded, which is under flow and events. And there we go. We can just pack this. We unpack it and then call it manually, just so that we can get the reference to us. So we call it, and then that way we will be able to see here for sure in DVs. Yeah, there it is. That's us. Nice. Now that that's done, we have our reference that we can permanently use for the rest of our code. Now we're going to get into some of the trickier stuff, which is going to involve some math, but I'm going to try to explain it in like the most common base way that I can. Move the sphere over here. Firstly, what we're going to do is we are going to get a dynamic input of type user. So we get our input and we input the variable name, which is follower user. I'm gonna grab the sphere over here, just put it underneath for now. Oh yeah, you know, if I could freaking spell, man. Hello weird. There we go. That works. Okay, so with this bit of code, what we can do is pack it. We're gonna double click on flux, create another child, and we're gonna name this positioner, I guess. So positioner flux, why not? There we go. So positioner flux. What positioner flux is going to be doing is giving it the exact position that you want it to go to. So I packed and unpacked this piece of flux here just so that, you know, it gets the user. Oh my god, if I could spell it correctly. There we go. And now, there we go. There we are. Very nice. I'm gonna put this inspector away. Okay, so now we're going to be working with what's called user root. User root is a data type that references your actual user's root. So if I was to select myself, I open the inspector and I come up here. Collider, I go up to the Farina main, I go up one more, which is right here, user stutters. This is my user root. So all of everything that you see here has to do with my user root. This is the literal user root slot, but what we're going to be dealing with is the actual literal data type of user root. First, what we want to look for is user root, so which is going to be under users that you can see here. This node right here quite literally just needs a user, and it outputs a user root data type. So normally when you mess with this node, you're going to be messing with things like finding slots like of the body that is underneath the user's root. The difference between an avatar and the user root is kind of like the avatar just exists under your user root, like as a flesh. You wear it, right? But you are the skeleton. You are the literal thing that controls the avatar. So kind of think of it like that. So we are getting data directly from the skeleton you. So we're going to plug that in. and this will output user root, which is great. That's what we want. Now what we want to do is get the head slot, which is going to be under users and user root. We plug that in. Now, as you can see, it gets the head slot, but it is underneath the user of stutters. So if I was to come here and I go all the way up to the user root, we can see that there is a head slot right here. But this is more specific to the actual user's root, not the avatar. We're going to be getting what are called get nodes, and we can get the vector of something. What a vector is in math is a line. So we have this line and it points in a direction. That is a vector. What we are looking for is creating an area for this thing to latch onto. We need to get the forward, we need to get the up, and we need to get either the left or the right position. In my case, I'm going to do the right. This will be able to help us determine where in this space over here we want to put this object. Probably around here, right? That's where they would all intersect. So we're going to get up, right, and we're going to get forward. Right determines X, up determines Y, and forward determines Z. Now, with all three of these, we can have them placed right here about, when we plug in this head slot, and it will now determine the vector directions of my head. So if my head tilts this way, the vector will understand what number it's closest to, depending on whether it's right, up, or forward. So for instance, if I'm looking for up position of something, right, and I have the up of my head, the global position would be like this. It would be X, Y, and Z. Well, let's do it like that. X, Y, and Z. So if I'm getting the up direction of my head, then it's going to be closer to 1 here. But if I point my head forward, it's going to be closer to this axis, and it will get closer to 1 on the Z. If I point my head in this direction, like this, it will be closer to 1 on the X, and we can actually check and see this. So this is what all these numbers mean here. So my head right here, we can see this is the Y. So it goes X, Y, and then Z. So we can see my head is closer to 1 on the Y. If I point my head forward, it's going to be closer to the 1 right here. And then if I point my head left or right, you can also see that value is getting closer to 1 on the X. So we can actually see this with the numbers as well. And it probably is a little complicated, but just trust me, it'll make sense. Now what we need is multiplication nodes. So we're going to look for mul, which is under operators, and we're going to look for one a little more specific, which is going to be mul float 3. We're gonna get it to look kind of something like this. So we're having each one have its own multiplicative value here. It seems a little intimidating, but all this is saying is essentially how far in this direction do you want this value to be? On the up, I want it to be only halfway, or on the right, I want it to be only halfway, and on the Z, only halfway. So that way, it understands how far on each axis that it wants to go. I'm probably just gonna do 0.5. Now that that's done, we can move on. This next part might seem a little tricky and a little confusing, but again, I'm just gonna explain as I go. Now what we need, a multi-add node, which is going to look like this. Again, it's going to be under operators. You'll just find multi, and then whatever, add. And what we're going to do is just add all of these together. So essentially what this means is now it understands the distance, right, that it should be at on each axis, but then it adds it together and it knows, oh, here, and here is where I want to be. So this area right here is the correct area. So that's what adding all these values did. So it's an intersective point. Well, let's take into account if you were to scale up and down, right? If I was to scale myself up and down, I don't want the object to just keep being the same size. I want it to also scale with me as I scale. So we're going to do user root global scale, which is under users and user root. This also is going to be connected to the user root back here. We grab another multiplication node, and I'm just going to copy the one here, and I'm going to multiply this by the user root global scale, which for me is 0.5 because I'm small. And now it's going to give us some other weird numbers that we don't quite understand until we put into context. Woo! This understands its point, right? It understands its intersection, and it understands that it needs to scale up and down based off of whatever your scale is by default. The problem is that it actually doesn't understand from what position this is supposed to exist on. Because right now it's just saying, okay, I know to offset myself from nothing. So we need to give it something to offset from, which is going to be the head's actual position. Remember, these are vectors, they are directions. So we need to give it the head's actual position. So we're gonna look for a head position, which again is under users and user root. And down here, let me bring this down a little bit. Yeah, there we go. So now we just connect this user root here as well, and we add this as well. I'm just going to duplicate the add node that I already have and just add these two together. And now it gives me some more weird numbers. All right, moving on. Okay, so we've gotten the vectors, right? We've gotten the position, which is the head. So now it understands where, right? And we have given it offset values. So we have given it 0.5 on the vector scale, which is going to be right around here, right? So it's going to constantly follow our head, probably right around this point. So the math is pretty much done. Now all we have to do is make sure, because the head position node is global, we need to localize it, which means that it is relative to the head, not the global position, right? So we're going to get what's called global point to local, local to local, which is under transform and conversion. But the problem is now, what are we actually localizing this to? We need to localize this to the parent of the sphere. So in this case, we're going to get the parent slot, which is under slots. We're gonna plug that in right there. And then we need this to be based off of the sphere. So we need to get the sphere's reference. So we get another input, dynamic variable object input of type slot. And here we will just do follower because that's what we called it. And there we go, and put it back. And now it just kind of exists over here, which is great. So we're getting to the final point of this math. Now this just needs to actually drive the position. I'll show you what I'm talking about. So we need an equals node to conditionalize. So we grab equals here and we say, okay, if the parent slot equals our root slot, then fire. So we need to get a user root slot node, which is under users as well. And this is just looking based off of whoever the user is, but this is essentially the exact same thing as if I was to just grab this and source it, but we're just doing it based off of whoever the user is. So it's a lot easier to manage. We're gonna put this up here, and we're gonna come back here, grab this and plug it directly into this user root slot. Probably something like that. That works. Okay. Pretty much all of this stuff right here is set up. So we just need one more thing, or two more things, which is a fire while true node to make sure that this is constantly updating when this condition is true, and a set local transform node. It will set the local transform of an object relative to the thing that it is parented to. So I'm just going to look for a fire while true node, which you will find under flow. We put this right here and we give it the condition, and then we also need it to run off of a user. So what we would just do is drag and drop this straight into this updating user field right here. This we can drive, and we can just set this up here. Now the final thing, all we have to do is just do a set local transform, which you will find unsurprisingly under transform. We're just gonna put it right around here. The position we are going to get from the global point to local data right here. And the last thing we want to do is probably give it a specific scale so that when it is being updated, it will just be that scale. So because the sphere originally at a scale of 1 was really, really big, we can set the scale manually here so that it doesn't have to be just tremendously, huge. And the instance is going to be the actual object itself, which is going to come from the dynamic variable input of our follower. And that's pretty much it. Now we just pack it and move on to the next thing. The next bit of code that we need is to create a distal check. So again, we're going to be working with the user root and the user and all that stuff. So we need a user input. We're going to get a dynvar input, and we're just going to put it right above right here. We're going to call this follower user root, and then we want head slot. So we get head slot, going to be getting what's called global transform. And that just basically has the TRS, which is transform, rotation, and scale data of something, right? So it has the global, which is right here, the global transform. We're going to plug in the head slot. So now this has the position, rotation, and scale of whatever object I put into it, which in this case is my head. Real quick, we're just going to pack this underneath, and we're going to put it underneath here, and we will call this snap checker flux. And then we go ahead and pack it and then unpack it. And now it has all of the data that we would want. Next, we need to compare it to the follower. So we're going to get another dynvar input and get slot, and we are going to get the global transform of this as well. So follower, and then we can pack it, unpack it, and there we go. So it says where it is globally within the world. These are its coordinates. We need a distance check. So we're going to go into the node browser. We're going to look for distance, and it's going to be an operator. Don't worry about which one it'll cast, and there we go. We have our distance. Now we can see that there is an actual value coming out of this. And the closer I get to the sphere, the lower the number actually gets. Now we need to turn this into a condition. If I reach a certain threshold or a certain distance, then do a thing. Because we're getting closer to the sphere, and after we pass this threshold, then do a thing, right? So we need to say if it is less than some amount. So we're going to go into the node browser, and we are going to look for less than, which is under operators. It doesn't matter which one, it will cast. So it is saying if this distance is less than some other number, then be true. True, false, true. And there we go. We've created a distal check. We don't want this to just snap every single time. So we only want it to happen when it is released. Ungrabbable release will be under interaction and grabbable. Get rid of this, get rid of this. And we are going to literally grab the grabbable on the actual sphere object itself. So we come into here, we go to the follower, and on here we can see the grabbable component is right down here. So we grab this grabbable component and we plug it straight into here. We can do an if statement. When released, the distance between my head and the sphere are less than 1, do a thing. That's all this is saying. All there is to do is just have this go under the user root slots. We need to parent it once this reaches a certain threshold value. 1 is a pretty big number, 1 to 0.5. And the very last thing, setting the parent. So we need to set the parent, which is going to be under slots. And here on true, if it is fired and it receives it on true, so we're going to plug it into the follower, and we're going to set the new parent as the user roots slot. So we need to do user root slot. We'll look it up. User root slot, which is under users. Clean up a little bit, and that should pretty much be it. So whenever the sphere gets grabbed, it will immediately parent itself under my user root, and then while it is parented underneath the user root, modularly, the other code will be able to register that and be like, oh, I know what to do now, because it is only when it is underneath my user root that it actually activates the other portion of the code. So I will pack this. If all is done correctly and I grab this orb, ta-da, I have created fake snapper. Ooh. Now, the only thing left to do when I move it anywhere else, like if I was to send this bitch to the moon, it still likes to snap on my head. That's number one. Number two problem is that it's still too big. So this is what we do. We unparent the follower to the world root, which you can do in the inspector, and you can just click world root, which is somewhere in here, over here somewhere. Well, it is at a scale of 0.12. So we're gonna just do 0.15, because why not? So 0.15 on the local scale. So when it sets it, it will snap to it, and then it will be fine. So on the snap checker flux, when I grab it and it is not within that distal check, if it fires on false, it will set itself back to the local user's space. What that means is if you're not directly under root, but you are under some other hierarchy, it will just set itself back to that specific space. User space, which is under users, and we're going to get another set parent. The new parent is going to be the local user space, and the object is going to be the sphere. And on false of it firing, if the condition is not underneath this check, then it will just set itself back to the local user space that it was in previously. And now if we check and we pack, now if I grab and it sets itself, great. And if I grab it again and it's not within that check, boom, it is now not permanently on me. So poofy, it just knows. It just knows. Yeah, so there you go. Whew, thank God, like all done. This is probably the longest video that I've made. I really hope that you guys watch all the way through and enjoy it. I really do enjoy making stuff like this. So if you guys have any suggestions on what you want to see in Resonite or like how to make something, please feel free. If you guys don't feel like making this yourself, I can put a link to the actual object and then you can just paste it from the clipboard inside of Resonite and it will automatically give you the follower. It's also going to be in my public folder, which I'm also going to share in the description down below. Thank you guys so much for watching, and I will see you guys in the next video. Peace.